Hey everybody, let's do some trigonometry review to get ourselves ready for the exam. Let's jump in. I'm going to go through this pretty quickly, but here's my key recommendation. While I'm doing this, I recommend that each time we get to a problem, before I begin to solve it, you stop the video and you take a good look at it. Can you solve it? Can you jump in and take care of that yourself? Or how far can you get before you get stuck and then need to start the video going and use my help? If you're able to do something without my help at all, you complete it, skip over that part just to see what my final answer is, you're good to go and you know you're ready to handle it. If it's something where you need a bit of help or a lot of help, that gives you the information that that's something you need to practice a little bit more. Okay, let's jump in and see where we're at. Number one, in this diagram we have angle AEB, and that equals angle ADC. So that's going to tell us that we've got some similarity stuff going on. Which statement below is true? Okay, so we got four statements here. With similar triangles, it's really important that we're looking at the order. The order of stuff matters a lot. So we're going to be looking for a situation where we've got the same angles and those angles are in the same order. So take a look and see if you can figure out which of these would be the correct one. Once you try that, I'm going to give you a look here. So I'm going to get out my highlighter and I'm going to tell you that our correct answer here is C. It's EAB is similar to DAC. How do we know that? Well, let's follow along. Let's start at E right here. And we're going to go up to A and then down to B. So that's how we're describing that triangle. That's the order we're going in. If I use my big triangle, I'm starting at D, which is a corresponding angle to E. And I'm going to go all the way up to A and then down to C. So the order that those angles are listed in is matching angles, right? So the same angles are listed in the same order. So that makes our similarity statement work. All right, let's move on from there and let's actually try solving with some similar triangles. So using similar triangles below, determine the unknown measure. Okay, so here in our first one, we've got two similar triangles, and we can match up our sides, right? And we can set up our proportion through two ratios and making them equal to one another. So here's what I'm going to do. I'm going to take my 12 and my 5, and I'm going to match up those two sides. So I'm going to say 12 over 5. Could you have said 5 over 12? Absolutely. You would have just had to make sure that the other ratio that I'm going to put right here matches up. So my big triangle is on the top, my small triangle side is on the bottom. I'm now going to match up 18 and x. So an 18 here and an x down here. Let's solve. We've got to do our cross multiply. We're going to end up with 12x equals 5 times 18. That's going to be 90. Divide both sides by 12. We end up with x is 7.5. Were you able to get there? Okay, let's try our next one. Let's try B. I've got two triangles here that are similar. I can see that I got one right here, and I got the other one, it's the little one right here. Okay, so those are our two similar triangles. And it's pretty easy to match up the sides the way they're sides and angles the way they're overlapped on top of one another. Okay, so we need to find x. The problem is this whole side of the triangle is actually 18 plus x, right? So that whole side of the triangle we got to take into account. So let's set up a ratio here. I'm going to start by matching the bottom sides 14 and 24. So I'll go 14 over 24. Could you have done 24 over 14? Totally, but that would mean the large side of your triangle is going to be on the top in both ratios. And now we're going to match small hypotenuse to large hypotenuse. So we're going to have 18 over 18 plus x. Okay, let's do my cross multiply game, like that. What am I going to end up with? Well, 24 times 18 will be on one side, that's 432. And on the other side, we've got a thing that's going to look like this, right? 14 times 18 plus x. So what would that work out to? Well, our 14 times 18 is going to be 252, and our 14 times x will be 14x. Okay, so now we got to solve for x. Let's subtract 252 from both sides. We end up with 180 equals 14x. Divide both sides by 14. We get x is 12.86. I forgot to put a box around my final answer before. How dare. There we go. Okay, were you able to get there? Were you able to set up your ratio properly? Did you remember that that big side would be 18 plus x? Or did you accidentally just call it x? Or were you able to solve from there? So take an assessment now with similar triangles. How do you feel about it? Are you able to match up the triangles? Are you able to set up your proportion? Are you able to solve? All right, let's move on to our basic trigonometric ratios. SOHCAHTOA. Let's see if we can solve for our unknowns here. We've got two sides that we need to find, and we have an angle that we need to find. Good idea to pause the video here, see if you can do this on your own without help, and take an assessment of where you're at with this type of mathematics, with using our basic trig ratios. Okay, so for our first one, I'm looking for my angle of 72 degrees. This is my opposite side. This is my hypotenuse, and this is my adjacent side. Now we got to assess which ones are useful to me here. I know the hypotenuse, so that's an important one. I need to know the opposite side, so that's an important one. Opposite and hypotenuse, that's our sine ratio. So let's set up our good old sine ratio. We're going to say sine, and then we put in the angle, that's 72 degrees. Sine is opposite over hypotenuse, so that's x over 36. Let's put this over 1 and do our cross multiply. 1 times x is just x. And then we've got 36 times sine of 72 degrees. What's that work out to? That's going to be 34.24. Were you able to get there? Okay, next one. Let's get rid of my highlighting. And let's jump in on this one. So here's my angle. I'm looking from the 40-degree angle. My hypotenuse is always my big side across from my 90-degree angle. My opposite is over here on the other side of the triangle. My adjacent is the one right next to my angle. Again, which ones are important to me here? So I would say I know the hypotenuse is important because I need that one. I need to find it. The adjacent is important because I have that one. So hypotenuse and adjacent. Hypotenuse and adjacent. That's going to be a cosine ratio question. Okay, so we'll say cosine of angle 40 degrees. Cosine is adjacent. That's 48 over our hypotenuse, which is x. Let's do our cross multiply game. 1 times 48 is 48. The other side, x times cos of 40. So I'll say x times cos of 40 degrees. Divide both sides by cos of 40 degrees, so we get x by itself. So we have 48 over cos of 40 degrees. And then I got to do some calculator work. That's going to be 62.66. Put a box around that. Were you able to get that answer? Okay, let's have a look at our last one. This time we're finding an angle. Let's do a little bit of highlighting in green. But first I need to write my sides of my triangle. So my hypotenuse is this one, as always. My opposite side is over here across from my angle. And my adjacent side is right next to my angle. Right away I can say it looks like I'm not interested in that opposite side. I don't know it, I don't need to know it. So which ones are going to be important here? Well, looks like the adjacent side and the hypotenuse are important. So adjacent side and hypotenuse, looks like this is going to be another cosine ratio question. So I tricked you. You probably thought, aha, it's going to be for sure tangent ratio because there's 3 of them. Nope, this is a cosine ratio question. So we'll say the cosine of angle x. Now I notice since I don't know the angle, I'm going to have to end up doing the inverse cosine at some point. I always have to do that whenever I'm calculating an angle. Cosine is adjacent over hypotenuse. Now you could figure out that that's 0.5, right? by putting that in your calculator, but I'm actually going to leave it as 12 over 24 just to show how we would do it if it wasn't such nice, neat numbers. So we'll do our cosine inverse on our calculator. We got to hit our second function button and then hit our cosine button, and then we can type in 12/24 and make sure we're using brackets so it keeps the division problem in the brackets, and we're not accidentally doing the inverse cosine of 12 and then dividing it by the whole thing by 24. So be careful with that. Make sure you can get this in your calculator. That should give you 60 degrees. Okay, were you able to get that? If you can do all three of these no problem, that means you got the basic trig skills that you need in order to tackle these sorts of problems. You can do your basic trig ratios. If you need a bit more help with this, this is something you're going to want to focus on. Remember, we can use videos. There's actually so many videos online that can help you with basic trig. You can ask me for help as well, but a good place to start is help yourself by checking out online. There's so many great resources. This is an easy one to find a little bit of support for. Okay, now let's try and apply these to some word problems. These get a little trickier. Number 4 is we got a plane approaching a runway. It's at an elevation of 2,500 feet. If the plane is 10,000 feet horizontally from this, that means on the the flat part, from the end of the runway, what is our angle of descent? So this is a little tricky. Let's pick out some important ones here. First of all, you should stop the video, see if you can draw your picture, and then play it so you can see my picture, and then try and solve your problem. Okay? So we know it's an elevation of 2,500 feet. That's going to be like my vertical height, right? That's not perfectly vertical, is it? But that's going to be my vertical height. Okay, what else have I got here? Yeah, so vertical height is going to be 2,500 feet. I also notice the plane is 1,000 feet horizontally, so that means I'm going to have like a horizontal thing like that. That's 1,000 feet. And then I notice I've got angle of descent. That's going to be angle of depression, right? So in this case, descent means that the angle the plane is taking to go down, but that would be an angle of depression. So from the horizontal aiming down. Okay, so let's try and draw this picture right now. I'm going to get rid of my highlighting, and we'll try and draw what this would look like. Okay, so I'm going to do my best to keep this kind of straight lines as best I can. So I said, okay, here's the height, that's 2,500. And here's my distance from the end of the runway, that's 10,000. This is not going to be drawn to scale. That's totally okay. And of course that makes a triangle, right? And it's a right angle triangle. Now I know my plane, this is the horizontal right here. And my plane has an angle of descent. That's going to be this angle right here. We don't know what that is, so let's just call that theta. That's a symbol we often use for an unknown angle. Now my Z pattern tells me that this is also going to be theta. So if I can figure out that angle in my triangle here, that's going to tell me the angle of descent as well, because those angles will be the same. Okay, now that you have this picture, are you able to solve this? Okay, now that you've paused the video and tried it out, let's write this out. This is going to be a tangent ratio. How do I know this is going to be a tangent ratio? Well, if I label my triangle for my angle, I notice this is the opposite side and this is the adjacent side, and those are the two angles I have. My hypotenuse I don't know, so it's not useful to me. If I'm trying to find an unknown angle, I need two known sides. So that's what I'm going to do. Now, tangent is, if we think about our TOA in SOHCAHTOA, opposite over adjacent. So opposite is 2,500, adjacent is 10,000. Let's do our inverse tangent of 2,500 over 10,000. Plug that into our calculator. What are we going to end up with? That gives us an angle of 14, if we go to one decimal place, 14.0 degrees. Okay, were you able to tackle that one? Were you able to draw your picture? Were you able to recognize it's the tan ratio and set it up? Okay, let's have a look at number 5. From the window of a building, the angle of elevation to the roof of a nearby building is 15 degrees. The angle of depression to the base of the same nearby building is 37 degrees. If the buildings are 65 meters apart, How tall is the nearby building? Okay, so we're going to need to draw a picture, some important information that we've got in here. We've got one angle of elevation that's 15 degrees. We've got an angle of depression that's 37. So we're going to be looking up and looking down from the same window, and the buildings are 65 meters apart. Okay, try drawing this before I do it for you. See how it goes. I'm going to draw my two buildings. So here's my one building. I don't really know how high that one is. I'm not going to have the math to figure it out, but here's my other one. Looks like this. Okay. And I'm looking from a window here. And so I'm going to be looking across like this. And I'm looking up to the very top, and I'm looking down to the very bottom. Now, these are not going to be to scale, because my up to the very top is 15 degrees. Angle of elevation, horizontal upwards. My angle of depression downwards is 37 degrees. And I know that my buildings are 65 meters apart, like that to that. So that also tells me that this side is also 65. This dotted line here. Okay? I want to find my unknowns, I want to find x, and I want to find y, and then add them together. Now, can I find them? Yes, for both of these right angle triangles, and these are right angle triangles, I got a right angle here and a right angle here. I know one of the sides, it happens to be 65, it's that shared side, and I know an angle. That means that's two pieces of information. I can find the third piece of information, and then add those pieces together to get the height of my building. Now, you might look at this and say, I'm going to add 15 and 37 together, get that whole angle, and try and turn this into like a sine law or cosine law problem. The problem is we don't know any of the outside angles in the, or outside sides, the side lengths on the outside of this bigger triangle. So we're going to have to actually do this as two right angle triangles and add them together. That's the only way to solve this. Okay, so what are we going to use? What ratio? So let's go, okay, good old SOHCAHTOA. SOHCAHTOA. That's the least neat writing of SOHCAHTOA I've ever done. We're going to roll with it. Okay, so which are we doing here? For both of these, I have the adjacent side. It's 65. That's adjacent to my angle of 15 and adjacent to my angle of 37. And for both of these, I want to know my opposite side. So I say, okay, adjacent and opposite, that's tangent. And it should always be a clue to me whenever the hypotenuse isn't involved, I should know right away that it's going to be a tangent ratio. Let's do our two calculations. It's tangent ratio for both of them. Okay, so we're going to go tan of 15 degrees. Tan is opposite over adjacent. So my opposite for my first one is x. My adjacent is 65. Let's put this over 1. Multiply 1 times x is just x, and 65 times tan of 15. Let's plug that into our calculator and see what we get. It's 17.42. That's my first answer. That's for x. Now let's do my other one. It's also a tangent ratio of 37 degrees. It's also opposite over adjacent, so that's going to be y over 65. The math is the same. So I'm going to go 1 times y is y. And I got 65 times tan of 37. Now I don't actually have to put this in brackets, the tan of 37. Just writing it like that is clear. That means 65 times tan of 37 when I write them together. Sometimes it can help to put brackets. In this case, I don't actually need them. So 65 times tan of 37, that's some calculator work. That's going to be 48.98. Okay, now we need to add those together because we need to get the height of the whole building. So the building is going to be 17.42 plus 48.98. So that's 66. Let's round off to 1 decimal place at the end here, 66.4, and that's in, that's got to be in meters. Meters. So 66.4 meters rounded to 1 decimal place. You might say, how many decimal places do I know to round off to? Well, you don't want to round stuff off too early, so keeping extra decimal places through your calculation is a good thing to do, and keeping it as an exact number in your calculator is even better. For final answers, if I don't ask for something specific, you can round off both sides and angles to 1 decimal place, and that'll be fine if I don't ask otherwise. Okay, so far so good. We're rolling along. Let's try these ones. Look like now we're getting into triangles that we don't know if they're a right angle triangle or not. They're probably not. In the case of the first one, we can actually check it just by taking 180 for our total triangle and subtracting 25 and 40 and seeing what we're left over for our final angle. So we're going to need our more complicated or more sophisticated tools in our toolbox. We need sine law and cosine law. Okay, sine law and cosine law. So cosine law would be a situation where we know all 3 sides and we're trying to find an angle, or we know 2 sides and the angle in between them. So I can see that for my second one here, that's going to be a cosine law problem. Okay. For my other one here, I'm looking to see if it's a cosine law problem. I don't have side, side, side. I don't have side, angle, side. That tells me it's probably a sine law problem. For sine law, we need matching side angle pairs. So here's an angle that I know. Here's a side that I know. That's a matching pair where I know both of them. Here's an angle that I know. Here's a side that I want to know. Those are the other matching pair. So that's going to be a lovely sine law problem. Okay, can you solve that? Go for it. Try it right now. Okay, you're back. Let's give it a shot together. So we're going to say, okay, to set up the sine law, I can either have the sine with the angles on the top, or I can have the side lengths of the triangle on the top. It doesn't actually matter which I do, because it'll work out the same as long as I'm consistent. So I could say, okay, let's put the sines of angles on top. I'm going to do the ones that I know first. Sine of 40 degrees over 5. What's my other pair? I'm going to go sine of 25 over x. Now if I had one of those flipped, that wouldn't be correct. My angles are on the top, my sines of my angles are on the top, my side lengths are on the bottom. Let's do our cross multiply game. We're going to end up with x times sine of 40 degrees on one side, and that's going to equal 5 times sine of 25 degrees on the other side. Let's divide both sides by sine of 40 to get rid of it on the left and move it over to here on the right. So x is isolated. Now maybe you can type all that into your calculator and that's no problem. Maybe you need to do it piece by piece. Find out what sine of 25 is, write it to 4 decimal places. Find out what sine of sine 40 is, write it to 4 decimal places. Okay, whatever you need to do. Writing something to 4 decimal places would be enough. So we end up with 3.29 centimeters. I'm going to work that out. Were you able to get there? Okay, let's try our cosine law problem next. We know all 3 sides. We want to find an angle, so that tells me it's cosine law. So with my cosine law, I have 2 versions of it, right? The version when I'm trying to find an angle looks like this. I'm going to say the cosine of the angle I want to know is going to be equal to, and then I'm going to set up this line here. Now can you set up the pieces and get them? Give that a try before I show you. Okay, so here's what we're going to do. The one we're subtracting is always going to be the one that's right here. It's opposite the angle. Okay, it's the one that's on the other side of the triangle. So I'm subtracting 10 squared. The other 2 sides are going to be 14 squared and 12 squared. Those could be in either order, but the minus 10 squared is really important. That's the one that's subtracted. We got to make sure it's the one on the other side of the triangle. On the bottom, we've got 2 times these first 2 sides, 14 and 12. Okay, so now it's a bit of math, right? 14 squared, 12 squared, minus 10 squared. Work all of that out. What is that on the top? On the bottom, 2 times 14 times 12. Work all of that out. And then we divide the top by the bottom. We're going to end up with this. You should get cos x equals 0.7142, and it keeps going. Keep that in your calculator, and then do the cosine inverse. What do you get? we get an angle of 44.4 degrees. Were you able to get there? Okay, so this should be a good test of, can you recognize sine law and cosine law when you need to do them? Can you set them up and solve for them? Let's try some more of these triangles like that. Non-right angle triangles. Okay, look at this one. What tool are we going to use for this one? Well, let's see. I don't see side, side, side. I don't see side, angle, side. So that tells me it's probably a sine law question. Do I have my matching side angle pair? Well, here's a pair where I know both of them. Awesome. And here's a pair where I know one of the two, and I have my one unknown. Perfect. That's a nice sine law problem. Can you solve that? Go for it. Okay, so let's set it up here. I want to know, now remember, x is an angle in this case. So I need to write it with sign like that, right? Over 37. Now you might have written the other one first. It doesn't matter which order you put them in, right? Whether you put this one first on the left or this one on the right, doesn't matter. So sine of x over 37, and then we've got sine of 32 over 43. Zero cross multiply game. We're going to end up with 43 times sine of x. Now I know I'm trying to get that angle x. I'm going to end up doing the inverse sine ratio at the end here. I know that's coming. And then I got 37 times sine of 32 degrees. Let's divide both sides by 43 so I can get sine x by itself. So I end up with 37 times sine of 32 over 43. What's that going to work out to? Well, we end up with sine of x is equal to, now this should be a decimal number, right? Or we've done something wrong. 4,559, and then it's repeating. Let's keep that in our calculator and do the sine inverse. I'm going to just move that up to here. So I'm going to say x is equal to the sine inverse of 0.4559, and it's repeating, or it's continuing, I should say. What do we get? We get 27.1 degrees. So were you able to get to 27.1 degrees? Could you get that working on your calculator? Okay, our next one. What do we use? Sine law and cosine law. Well, I know cosine law is an easy one to look for if I've got side, 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 which I don't. I don't know all three sides. So it can't be that. What about side, angle, side? Aha, I know a side, I know an angle, and I know a side. The angle's in between the two sides that I know. That means I've got a cosine law problem on my hands here. Cool, let's do it. Okay, so how do I set up my cosine law when I'm trying to find a side? Well, I say, okay, the side I want squared is going to equal the two sides that I know squared, 25 squared and 34 squared. And then I'm going to subtract. So that looks like Pythagorean theorem, right? And then I got to have my adjustment factor here to make this into cosine law. 2 times the two sides, 25 and 34. And then I got my cosine of 32 degrees. Now it's super important when you're doing this, right, that this side, oh, that's too dark. Let's try that in yellow. That this side, side x, and this angle are the ones that are across from one another. Okay, so that's the angle I'm going to use. It's really important to recognize that. Here we go. So let's simplify this. 25 squared plus 34 squared minus 2 times 25 times 34 times cos of 32. What does that work out to? You should get 339.32. If you don't, that means you're doing something wrong. The most common mistake students will make is they don't treat this all as one term. They do adding and subtracting before they multiply all this stuff. So you have to do this first, order of operations. What is 2 times 25 times 34 times cos of 32? You're subtracting that whole number. Okay? Depending on the size of the angle, if it's bigger than 90-degree angle, this might be a negative term. If it's smaller than 90-degree angle, it'll be a positive term. So just be really careful with your signs. Work all of that out, figure out what that is as one big term, and then you can add and subtract your three terms. Okay, so make sure you can get there. I want you to test yourself out on that and see how it goes. Let's take the square root of both sides. to get x by itself rather than x squared. So that's going to be 18.4 meters. Okay, so cosine law. How are you doing with cosine law? Is that something you need some practice with? Are you okay with it? How about with sine law? Is that something you can set up and get to a final answer? Or is that something you're having a little bit of trouble with? For number 7, what's the area of the triangle in D above? We're not actually going to do that. So we're going to cross that one out. You can scratch that. I'm not putting area of triangles using trig on the exam, so you can ignore that for now. Okay, let's get into last couple things, kind of word problem-y type of things. First one, Allison is flying a kite. She's released the entire 150-meter ball of kite string. She notices the string forms a 70-degree angle with the ground. Mark is on the other side of the kite and sights the kite at an angle of elevation of 30 degrees. How far is Mark from Allison? So I'd like you to try and draw this first. See how it goes. So pause and try drawing it. Okay, you're back with me here. So here's Allison right here. And Allison has let out that string for the kite up to here. And I can also draw the ground like this. Right? Now, somewhere over here, we've got Mark, who's on the other side of the kite, right? Our kite is up here. Mark is on the other side. Let's get rid of this little tail end here. And we also know some of the angles. We say with Allison, it is, I've kind of got my, like, this wouldn't have to be drawn to scale, but I kind of don't like how I've drawn that. Because Allison's should be 70, so Allison should have a bigger angle. So I'm going to actually redraw that. I'd like to do that, make it look a little more to scale. Okay, so here's Allison. Allison is seeing the kite up at 70 degrees. Mark is seeing it at a lower angle, about 30 degrees. Not about, exactly 30 degrees. There we go. Okay, so to Allison, the string is 70 degrees with the ground. Mark's over here. And for Mark, that's 30 degrees angle of elevation. Okay, so there's my triangle. How far apart are they? That's this right here. Can we get an answer from this? Well, there's one more piece of information that we know. We know that the string is 150 meters long. So, have a look at that diagram. See if you could calculate that from here. Okay, so you've tried to calculate it. I notice that I've got a known side angle pair. Now my problem is I want to know this, but I don't know this angle right here. Could I figure that out? Well, yeah, sure, I could figure that out. How do I figure that out? Well, I got to say, okay, well, we got to go 180 degrees in a triangle, minus 70, minus 30, the angles that I know. What am I left with? I'm left with 80 degrees. So I know that this one is actually 80. So there are situations where you'll know 2 of the 3 angles and you need to calculate the third one. Okay, let's set this up. So we do have a sine law problem. I'm going to say my sine of 30 degrees over 150. That's my known ratio. How about my one where I don't know one of them? Sine of 80 degrees over x. Sounds good. Can you get to the answer from here? Cross multiply. X times sine of 30 is on one side. 150 times sine of 80 on the other side. Divide both sides by sine of 30. Gives us that. That's a bit of calculator work. Can you get there? You should end up with 295.4 meters. And this is a word problem, so we can do a little therefore statement. We can say therefore Mark and Allison are 295.4 meters apart. Okay, word problem-y stuff. Last one here. A boat leaves Kingston and heads in the direction north 60 degrees east for 25 kilometers. At the same time, a second boat travels in a direction 30 degrees south of east from Kingston for 15 kilometers. How far apart are the boats at the moment when they reach their destinations? I'd recommend for this that the first thing you do is you just recognize that these are two boats coming from the same spot. So they start at the same point and then they move out from there. Okay? I'm also going to recommend that you make yourself a little Cartesian grid, kind of like this, because I find this can be really helpful. And so Kingston is going to be right in the middle there, and we're going to see our two boats come out from that. Try and draw a picture right now without my help. See how it goes. Okay, you're back. That's awesome. Let's keep using our line drawing tool actually here so I can have things that are nice and straight. Let's use red lines. Okay, so my first one, I've got a boat that leaves Kingston north 60 degrees to the east. That means we're going to look north. In this case, that would be up. And you know, I should probably write that on here. So let's go north, south, east, west. Okay. Cool. So we're starting at Kingston. We're going to say that's here in the middle, and we're going to go 25 kilometers. And we're starting up here north, 60 degrees to the east. 90 degrees would be the whole way east, so 60 degrees is 2/3 of the way, so it's kind of like something like that, right? That looks about right. Let's turn this into a lovely vibrant red. I like that better. Okay. And now we have another boat that leaves from Kingston, and it goes 30 degrees south of east. So east would be here. 30 degrees south of east would be 30 degrees down from that. And it doesn't go quite as far. It only goes 15 kilometers. So that's I'll make that one a little bit shorter. Something like that. Okay? Now we notice that does make a triangle, so I'll add my third side on here. Let's do a little bit of labeling. We know this one is 25 kilometers. We know this one is 15 kilometers. We don't know this side. I'll call that x. We know that this angle is 60. We know that this angle is 30. So we can figure out the rest. This angle inside, because this whole thing, right, this whole angle has to be 90. So if we subtract the 60 from there, that means we got 30 left over in here. So that means this whole angle, 30 plus 30, is 60 degrees. Okay, can I solve the triangle now? I've got two sides and an angle in between them. Two sides and an angle in between them is a cosine law problem. So, cosine law. I'll say the side I want to know, we'll call that x. Squared would be the two other sides, 25 squared and 15 squared, minus 2 times 25 times 15 times the cosine of 60 degrees. Remember, treat that whole ladder thing as one term. Let's work that out. I'm going to leave that up to you, but you should be getting 475. 25 squared, 15 squared, those are added. We're subtracting all of this other stuff. Okay? So, that's x squared. So x is going to be the square root of 475. What's that work out to? 21.8 kilometers. Let's throw a therefore statement on there as well. Therefore, the boats are 21.8 kilometers apart. Okay, time for a little self-reflection. Where are you at with each of these things? Are you having a lot of trouble with word problems? Are you having trouble figuring out when it's sine law or cosine law? Are you having trouble getting the right numbers when you're using, say, cosine law to find the side in a triangle? Can you use your basic trig ratios? How are you doing with similar triangles? Take stock about where you're at and make a point of noting down right now some of the topics that you're having the most challenge with. Those are going to be some areas we want to focus before we get to our exam. Okay, we'll stop it there. Thanks everybody for joining me for this review.